So I made these slides because I was trying to like break up and understand this sort of essence of context engineering, or kind of like come up with some things about like the what kind of information I derived from learning about context engineering. And so I made these slides and I gave a talk at my work, but because I was talking to other engineers, it was a little bit more specific to what we were doing there. So I wanted to make one that was a little bit more general, right? And context engineering generally has like two tracks. All right, one track is if you're building an agent, and by an agent I mean like a the Claude CLI or whatever, or like a chat sort of app. And you're basically going to be collecting chats from the user and then sending them through some sort of endpoint API to get responses back. And so you have to kind of like manage the context and send it along and make it work that way. That's not the way we're going to be talking about here. We're going to talk about how understanding context engineering can help you when you're actually making prompts. So it's kind of like, I guess, a superset of prompt engineering. Um, and you have to kind of be careful in the industry right now because there's lots of people who basically make most of their money by speaking. And in tech, you always have to be careful about people who are not actually making software. They're just making talks about software. And when the way you get your paycheck is by having something to say, well, you'll always have something to say because you need to get paid. And it doesn't matter if it's actually useful or helpful or just sensational. And eventually you learn that like sensational claims like, prompt engineering is dead. Now it's context engineering. Well, prompt engineering is not dead. It's still totally relevant. How you construct your prompts is very important. And context engineering is also very important, kind of like having a general understanding of what's going into the context. So when you have this LLM sitting out there in space, like it really is, it's just a big bunch of matrices of stuff. So when you send text to it, that text gets tokenized. The tokenized is not really a word, but we'll just kind of like use that idiom for the moment. So you have like a certain context window, and that context window is going to get tokenized, and those tokens get converted to these things called vector embeddings. That's all kind of baked into the model. It's trained on those. It kind of ends up encoding the semantics of the tokens as well, to a certain extent. But all of this basically gets like boiled down into that, right? Because the model is just like you have like this pass through it where it basically is like a sieve. You convert all your tokens to vector embeddings and then you pass them through this multi-layer matrix of weights that applies some basic functions, and then they basically create probability of the next token. The model then selects the sort of code that is executing it, selects the next token, appends it, and then basically passes it through until it's ostensibly done. Okay. And all the sophistication on top of this, all the delineations on top of this, those are totally like human and user space concepts, because at the end of the day, all of this has to get basically collapsed down into tokens and pass through this model the way that we're talking about here. So we as humans, we kind of break this context window up into, I guess, what you could call like instructions. Those are like the things you should do. Knowledge will be like, explaining what things are, how they work, and then what tools are available, right, to the model. And all of these things are just going to get converted down into tokens at the end of the day. Like there is no special thing. Like the Anthropic API sits between its model and you, and it takes a list of tools, but ultimately that is going to be converted to tokens too. Like the model has no additional API that it uses. It just has vector embeddings that they pass through, and then what comes out the other end is the answer to your question, or another question, or a suggested tool use, and so on and so forth. And so when we start talking about context and context engineering, what we're looking out for is a series of problems. At least these are like the most important problems. And the maybe we could all generalize these. We can call these like context rot, maybe, or something. But all these terms are a little bit fungible. But generally speaking, we kind of like can break it up into four categories. There's this context poisoning, context distraction, context confusion, and context clash. And poisoning is when, during this process, right, where you pass tokens in, and obviously the model predicts the next token, selects it, appends it, passes it back through. As it's doing this, because of the nature of the model, it's going to make inferences, right, about some of the information. And when it makes a wrong inference, right, like it says, oh, I realize that X is true, but X is not true. Once that's kind of in your context, then that that is kind of poisoning everything. Because even if the model comes back and says X is true because I realize X, Y, and Z, and then you're like, no, 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 it's totally not. And then the model's like, okay, then explain to me what it is. And you explain it. But as long as you leave that bad inference in there, your context is effectively poisoned because of the way that all this gets converted to these vector embeddings that are being passed through this matrix. And there's kind of like an attention mechanism about like which tokens link to other tokens and which tokens cause like the attention. And at any point in time, the model could wrongly decide that it should be paying attention to that bad inference, not the good one later, right? Because it doesn't really think, like it's not like a human, right? So it could be focusing attention on this poison context, and now it's gonna keep having problems. Like it'll continue to make bad inferences because it'll say like, well, this is true, therefore this new thing is true, and now you have two bad inferences in it, and so it just gets worse and worse. And then context distraction is when there's information that's just not useful, right? Like it's just taking up space. This could be like the result to a tool call that didn't lead anywhere, or information that doesn't really have to do anything with the current goal or the current context. And it's just stealing attention, right? Because remember, like this, we have this mechanism where we have these sort of large vector embeddings, and the tokens can kind of like relate to each other. And there's like this attention mechanism of what to pay attention to, right? Because it can't pay attention to everything all at once. And so it's entirely possible with this context distraction, like it will just be having in its attention things that just absolutely like they're not bad, they're not good, they're not helpful, they're just distractions to it making inferences. They're not leading to anything good or necessarily leading to anything bad. They're just like they lead to lower quality performance, essentially, is what distractions do. And then you have sort of confusion, which is probably kind of like a little bit close to distraction, but slightly different. And this is where it just has things that are ambiguous, that aren't wrong. They're not necessarily wrong inferences. They're just sort of like confusing the matter. It's like extraneous details that are both kind of true and maybe useful to some other part, but because of where they're at in the context, they're just kind of like confusing the situation. I kind of look at context distraction and confusion as kind of like maybe it should have just been 3 instead of 4, but they're kind of like distinct in a sense, but maybe it's a little bit nuanced of how they're distinct. And just like kind of like look at it from the difference of like a person who is confused is not the same as a person who is distracted. A person who is confused has maybe like a missing piece of information. They have like 3 of the necessarily pieces of information and one is kind of missing, and so now they're confused about things, but none of them are wrong. And you don't necessarily want to like eliminate context confusion. You want to identify when the context can't lead to a quality inference or a quality action, right? Because it's confused because it doesn't have the answer. And so maybe it makes an assumption. And usually, generally, when models make assumptions, that's when you start getting into trouble. And the other problem is context clash. And context clash often comes from what we call a sharded conversation. So if you make a very big and complete and well-detailed prompt and send it off, and the model can just say, oh, I have all the information, and so it just goes and does it. That's one way. But a lot of people want to have a conversation with the model, right? So each time you type like a few sentences, and then the model responds, and you type a few more and stuff like that, and you keep sort of like adding in details, right? And we call this kind of like a sharded conversation because it's multiple steps. The chances of you basically saying, hey, let's do X activity, and you start clarifying it, and then you realize that X activity is probably actually not what you should be doing. It's like, actually, let's do Y activity. and let's go ahead and do that. And the problem now is that you have two aspects of this conversation: do X and do Y, and they're kind of like clashing with each other. So that can cause some issues. There's also ones where you have like logical clashes where you like tell, like you've established never do X, and then you establish a situation where it has to do X, and now it's got a context clash where it's like, well, you said never do X, but obviously like never say never, and now you sort of caused a little bit of a problem in your context. And so these are kind of like the four general areas when you're interacting with an LLM that you need to like be considering is like look at your context, debug your context, and say like, do I have bad inferences? Do I have distractions that are just like sort of detracting from the model, or do I have like confusing elements? Am I missing something? Is this not really explaining it, or do I have clashing directives, or am I setting up a situation where there could be clashing directives? So the first principle that I've learned is like, and this is again like never say never. Never say never, because there are situations where you can kind of fix stuff. But generally, it's a bad idea. So the general um, advice when you kind of distill everything down is never steer, always clear, right? Like if things get off the rails, trying to get them back on isn't helping you, because even if you've seen the model go in the wrong direction with some wrong inferences, and then you stop the model and you correct it, and it says, oh, now I understand, it doesn't matter because of context poisoning, right? That stuff is still in your chat context while you're sitting there chatting with the model. So it doesn't matter if from the last message it says, oh, now I totally understand, and it gets it right. It won't matter because that context is now poisoned. So never steer, always clear. When you get into those sort of situations, you always want to clear. Sometimes the bad inference or the bad, like sometimes this is okay when there's like a bad tool use, like it uses the wrong tool. It does this very often when you're working in like a repository that has like, or on a project that has some unique build needs, and it thinks, oh, this will just be like a regular build system. And then you have to press escape and stop and say, no, 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 use this other build system. That's probably okay. That's not a big deal. So again, never say never, but as a general rule, never steer, always clear. Like always start with a fresh context. And we're going to talk about like ways in which you can preserve context across sessions. But generally, you don't want to fight with the model when it's making mistakes, and you don't want to trap bad inference in your context because it will come to bite you later on. So this is what's the best way to explain it? So I call this telling the story backwards, and it kind of goes like this: when you are talking to a regular person, you generally want to start with like a 40,000 foot view, and then like a 30,000, 20,000, 10,000, and you want to keep getting lower until you get to the real problem, right? You want to give them like a general framework for understanding what the problem is, and then you want to keep like ameliorating and expanding that, right? And that's kind of like the way you interact with humans, and that's generally like a way that we found that it helps humans to get themselves situated in the context. And humans are very good at tracking context, a far better than AIs have been or currently are, LLMs at least, right? But that does not work for an AI. In fact, that is literally the worst thing you can do for an AI. You will get very bad performance if you start from that, because you need the AI to have as its central, of the first thing that it encounters is what it's trying to do and maybe even who it is. You want to essentially um, tell the story backwards. You want to start with the end of the story, what you're trying to accomplish. And it doesn't matter if there's no context or there's jargon or any of that stuff, because as you go on in your prompt, you're going to explain the jargon. If you do it the other way around, the model will have a lot more trouble keeping track of the goal of what you're actually trying to do. So if your goal is to write some sort of piece of software, then you start by saying, we're going to write this flibbity jibbity widgety woo software in Python or whatever. And then you keep going and you explain what fibbity jibbity and widgety woo is, whatever those terms mean. But you always start with the flibbity jibbity. Like you don't say like, okay, look, we have flibbities and we have jibbities and then we have widgety woos. You don't start with that because that's how you start with a human. You'd say like, oh, we have these three components and then we want to build the software that uses all three components. No, no, no. You start by saying we're going to build the software that uses the three components, and then you explain what the three components are. You essentially tell the story backwards to the AI or to the LLM. So always like kind of start with the goal, start with the end in mind, and then explain until you basically start at the 1 inch view or the worm's eye view, and then you go to the just the regular person's eye view, and then the bird's eye view at the very end. And that seems counterintuitive, but that's actually the best way, or you'll get better results if you do it that way. So now this is kind of a little bit specific to, well, I mean, it's useful for almost any kind of usage. And I don't intend to get into a philosophical or scientific argument about AI and whether or not LLMs are intelligent. But I feel that in practical terms, if you stop looking at the LLM as an artificially intelligent thing, then you'll stop judging it in terms of its intelligence. If you start looking at like it's a programmable computer, and I give a couple of different examples, but I think probably ultimately the best one is, at least for a technical crowd, is to think of it like a compiler. And the thing is when you make some source code for a compiler and you run the compiler and you don't get out what you expect a running program that executes. And when you don't get that running program that executes, you don't say, my God, this compiler is dumb, or compilers aren't ready, or any of that stuff. What you do is you say like, oh, I must have made an error in my source code. If I didn't get the program I intended, I must have made an error in my source code. And your context, the context and the prompt that you inject into the process, that's your source code. Because essentially an LLM is like a robot. It can do stuff, but it only does things that you tell it to do. It can only make inferences based on the quality and precision and applicability of the facts that you provided. So just because you give it a fact that's true doesn't mean that that's helping your problem, because maybe that true fact doesn't actually apply to the solution. So it could be like, this sort of context distraction. If you think about it this way, like you'll have much less disappointment, because when the model uh, does something that seems smart, you're like, oh, AI is so awesome. And then when the model does something that's dumb, you're like, oh my God, AI is so dumb. It's kind of neither of those things, right? It's neither of those things. It's your context has been kind of the problem. And so that means that your focus on, when the model doesn't produce the results you want, your focus becomes debugging the context, just like you would debug the source code. And you would like make sure that the information that the model has available to it for making its inferences um, is good and quality. So the debugging an LLM is much easier because it can help you understand why it doesn't understand, right? So it's far easier to debug a context than it is to debug like a C++ program, because you can load up the context that you gave it, and you say like, hey, given this context, answer this particular question. It gets the question wrong, and then you can say like, well, what makes you think that? What facts did you use? Like, what was your chain of reasoning? And then it will say, oh, well, you said X, Y, and Z, and I implicitly said, well, logically, then this Z prime would follow. And you're just like, okay, well, that's definitely wrong. And then you can kind of see like, oh, my context misled the LLM to make the wrong inference. So you want to debug your context as if it were a computer program. And so this is more of an applicability at kind of at work when someone else is paying the bill for your API charges. But in general, when you're building up your context for like complex things, what you want to do is you want to burn as many tokens as you can in the early stages to make the context really good. And then from then on, as long as you're reusing that shared context that you burned a lot of tokens on, you don't have to reburn them to make the context. Because when you're, say, for instance, writing like a piece of software, in order to accomplish writing that software, the system has to, the LLM has to explore the source code with tool calls to read files and so on and so forth. But if you do all that up front, burn all those tokens and say, hey, use this context as your model for understanding how to do this process, or you make like a plan document to do that, and you burn lots of tokens in the plan, then the execution of the plan, you have to burn fewer tokens, right? So you kind of want to like burn the tokens as much as possible early in the process. So the one thing that you want to try to do, because again, like we said, like, never steer, always clear, and you have a limited context window. So how do you have multi-session conversations? Well, the way that you do that is that you start up a conversation, and then you get it to a certain point. You sort of watch your context, make sure it doesn't explode. Try to keep it like under 50% context usage. And when you get to that, then you say like, okay, let's summarize all the things you've learned so far into like a context markdown file. And then you can clear and you can load up and you say, hey, we're working on this context markdown file. Let's continue to expand and learn about this particular problem that we're working on, right? And what you can do then is now you have a debuggable file that you have on disk. You can read that file and then you can go say, oh, you can identify problems in the context and then you can correct them. Or you can correct them in successive conversations. You can say like, hey, in this file, there's this wrong assumption. Let's fix it. And then you fix it and then you have it updated, right? It's disk. And then you clear and you start the thing again and you load it up and then you just keep building up this file. Because remember, like a 200,000 token context window, that's 150,000 words. That's a book. That's basically a book worth of stuff. So you can actually make these documents quite detailed and you can continue to optimize them and you can continue to refine them so that you can like work towards the solution to your problem. Like your problem could be a piece of software, your problem could be a research project. Like I want you to research these things and make connections, but you kind of have to like provide it with that information. And one easy way to do that when you're doing like this chat modality where you're chatting with it is just have it write it to disk, clear, load it up, continue. And that way you kind of like it's a more controlled thing, because if you use forward slash like compact like in Claude CLI, it's a very generic summarization kind of stuff. Like you don't want it to do that. Like it might summarize things that you don't want it to summarize. So be like very specific. So always be updating. So when you're working on things like this, don't, like before I said like, oh, when you get to 50% saturation, you should write it out. Actually, you should not do that. Like you should be writing it from the start. You should say like the goal is to write this document. And every time you establish a new learning or a new correct inference or new pieces of information, you need to have the model like write that to the context, because there's been, first of all, like the CLIs and the interfaces, they have bugs. Like you definitely don't want the bugs. Um, so you need to have it constantly like updating your context so that you can load that context back up and continue. There have been many times where I have lost hours of work talking way too long with the model and expecting that it would be able to like summarize at the end of our conversation, realizing I'd gotten too far in my context, and then like a bug shows up. Like when you use some of these sort of chat kind of systems, uh, for long enough, you end up running into a lot of bugs. They are not very reliable. So this is kind of like the control S, like constantly save. Just keep saving, keep updating. So always be updating. Um, and so this kind of links back to what I was saying a little bit earlier. I think when I did the talk at work, I reorganized these so they were a little bit closer, because this is kind of like relates back to this sort of debugging the context, where it's basically like, it's not that the models are weak or bad or stupid. Though that can be the case in some instances. I mean, it depends on what kind of work you're trying to do. But for the most part, the real problem is that the context that you fed them and the information that you're giving them to work on is the weakness. That's the weak part. And you have to strengthen that, and that will get you far better results. And the other thing is like, so don't just use tools, and this really depends on how you're using any of these models. But you can actually get the model to make a tool which does various other tool things, because tool calls tend to poison your not necessarily poison your context, but definitely like cause a lot of distraction in your context. They fill your context up, and many of them are useless. Many of them are actually not leading to anything worthwhile. Like when the model is trying to find some information, so it reads 5 files. Those reading of those 5 files have now jumped into the context, but maybe the information was only in one of those 5 files. So the other four, you don't even need that context. It's not helping you. Like it's not helping you. So you want to get rid of it. So when you're doing like long running repetitive processes, like what you can do is just say like, hey, I'm going to make a tool that goes and looks at a bunch of different files and finds some information that I need, and then just returns that. And so you can just use tools. You can make tools and you can use them from inside the model, generally speaking. And one thing that you might be surprised to learn is that tools can call models. So because you can, like, say for instance with Claude, you can run Claude in headless mode, or you can use something like LangChain or these other things, or Pydantic. There's some sort of Pydantic thing that you can use as well. I've never used it specifically, but you could. Um, and you can basically write in sort of Python or some other code a tool that does something, and that tool itself can actually use the model API to call the model, or you can just execute a headless Claude process with like Claude minus p to work on some of the intermediate output. So you can make tools, and those tools can call models, and those models can call tools, and so you kind of have like this toolception. So you can make things better by adding these additional tools into the mix that can help you solve certain problems. Some of them can be like, fetching context, fetching web pages, accessing a database with information, and so on and so forth. So like if you have a website and you have a bunch of information in your MySQL database, and you're like, well, I have to make this model read the website, but there's going to be a lot of gunk on there that it doesn't need. So why don't you just make a tool that just, goes to the website, goes to the database and pulls the information out in some sort of raw format and provides it to the model. And then it basically now has this ability to go find the information and read it directly. And one of the things that I have kind of learned over time, and this is because I have to work in a lot of different kind of environments. So I think maybe on the case of like most people's, if you're just developing in like a virtual machine, maybe it doesn't matter quite as much. But I have found that I get better results when I generate the tools in Rust instead of like Python. Sometimes you have to use Python, or sometimes you have to use JavaScript, whatever it is. And it's not about what's your favorite language. It's more about there's a unique feature of Rust, which is that Rust has this sort of way that is organized so that if the application compiles, the chances of it actually being correct are substantially higher than almost any other language. Um, and so a lot of the types of errors or mistakes that a model will make while generating a tool, they'll get caught at compile time by the Rust compiler. So you tend to get better one shots of tools, uh, and you tend to get better like debugging. Um, and I don't think I have it here, but one of the things that when you're making a tool with an AI, like you're using it to write the code, you want to become like absolutely insane about logging. You want to make sure that it's logging absolutely every single decision, every single action, every button press, like huge logs. And the reason being is you want to be able to debug those tools with the model itself. So you basically, like, when things don't work, you just basically go to the model and you say, hey, I told you to make this tool. I did X, Y, and Z. I expected this result to come out and it didn't. Look at the logs, look at the code, figure it out. And you'll get a lot of good results this way when you're using the AI itself, or the LLM to manage the tools. So definitely recommend using Rust, not just for memory safety or stuff like that. I think that that ultimately doesn't matter in this particular case, but just because it's easier to debug. And Rust is a popular enough language that most models have had a good amount of a good amount of experience with it so that they can write pretty decent Rust code. So sub agents, use them judiciously. Like I use them, sometimes they're good, but the problem is that they often kind of um, they don't get around the problems of context engineering because whatever context you have when you launch the sub agent, it kind of gets that context as well. And so any sort of problems that exist in your session are just going to be communicated to them. And so one of the things like you think that you might want to do, like yeah, at some point you'll kind of realize that you can use a model to generate some tool or some code, and then you can also use that same model to evaluate the code and find bugs. But you cannot do that in the same session. Not even with subagents, because they are all colluding together when they are sharing. Like they seem like if you have a problem in your context where you have a hallucination, you hallucinate some API. So the first agent goes to implement something and it completely hallucinates an API. When the second agent gets spawned to evaluate what the work of the first agent, it has the same hallucination. So it's like, oh, of course this API is great. Code is awesome because it's also like sharing the hallucination. So use them judiciously, but don't think that they're going to solve your context engineering problems because if your context is not well set up and tight to begin with, they will basically just multiply the errors. But if it is set up well, they can help you kind of like control the context explosion and you can do slightly larger tasks with them. But for any like truly non-trivial task, like subagents is not the way to go. Like it's just you cannot run uh, a single process for. I mean, like I've run the max one I've run, and I get like a lot of hallucinations. But even with like really tight context engineering, you can have one that's running for maybe like 25, 30 minutes. But that's really pushing it, and the chances and the chances and amount of hallucinations are quite high when you start getting to that long running thing. Is you generally want to like run them independently or individually as individual sessions. Um, so I do have like some links for some further reading about things like maximum context window and maximum effective context window. Some articles that I read that went into like making this. And you're welcome to look at them. There was probably like a whole lot more that I read that was involved in this, but here's like a starter sample of some YouTube videos and some papers.